Welcome to the fourth episode of our series on probability. Before we explore topics, I recommend watching our previous videos as they provide essential context. In this episode, we are exploring random variables, specifically the probability mass function and Gaussian distribution. Random variables are fundamental in probability theory as they assign numerical values to outcomes within a sample space. For instance, consider an experiment of tossing two coins, resulting in four possible outcomes of two heads, one tail, one head, and two tails. To map these outcomes to numbers, we can use the count of heads. One head and one tail and one head both have one head, while two heads have two heads and two tails have zero heads. This mapping defines our random variables representing the number of heads. We can visualize this by creating a probability distribution. For non continuous variables, it's called a probability mass function, where we plot the probability of each sample in a 2D space. Conversely, for continuous variables, we use the Gaussian distribution characterized by a bell shaped curve. It features important properties such as central tendency, with the mean, median, and mode all being the same. This is just the tip of the iceberg. But before concluding, let's also talk about cumulative density function or CDF. It's used to plot the cumulative probability of discrete random variables. The CDF is cumulative, meaning CDF incorporates the probability of x plus the probabilities of all smaller values. At the end, the probability reaches 1, representing total probability. I hope this episode provided valuable insights and we'll continue to explore more topics in upcoming episodes. Till then, thanks for listening and thanks for watching.